All right, Math 201 students, this is some extra examples that we did not finish in class on Tuesday from section 2.7 and one from 2.8. So looking at number 8, this is the section on implicit derivatives. So section 2.7, it says find the equation of the tangent line to the graph of 4xy plus x squared equals 5. That is a function that you could solve for y if you wanted to, because there is just a single y. But we can also do this using implicit derivatives, where we take the derivative of each term individually with respect to x, and we chain on a dy dx anytime we take a derivative of something with a y in it. So because this first term is two different functions essentially times each other, it's a product rule. So I'm going to write my first function is 4x and my second function is y. The derivative of 4x is 4. The derivative of y would be a 1, but because it is not with respect to x correctly, we tack on that dy dx. So because y is its own function. So when we have a function composition, essentially, we always have that chain rule to attach. So then remember, for the product rule, you do the derivative of the first function times the second function. So this would be 4y plus, and then we do the first function times the derivative of the second function, which is 4x dy dx. Then we move on to our second term. X squared is just going to be 2x, no chain rule since it is with respect to x, and the derivative of 5 is 0. So our next goal is to get everything that does not have dy dx to the other side. So we'll subtract over the negative, it'll be negative 2x and a minus 4y, and then we'll divide by 4x. Now at this point, because everything is divisible by 2, we could reduce here. So you could write this as dy dx is negative 1x minus 2y over 2x. That would be in reduced form. It doesn't technically matter because the next step is going to be to plug in our ordered pair for both x and y and to find, remember, our slope of our tangent line at the point x equals 5. So this would be negative 5 minus 2 times negative 1 all over 2 times 5. So that's going to be negative 5 plus 2 over 10, or negative 3/10. So that's my slope. Now all we need to get an equation of a tangent line is we need a slope and a point. So we have y minus negative 1, so that'll be plus 1, equals negative 3/10 times x minus 5. You can distribute the negative 3/10 right here. So that would be negative 3/10 x, and then this would be a positive 15 over 10, which will reduce down to a 3/2. Divide both of them by 5, and then we need to subtract over the 1. Now when we subtract over the 1, we'll have to make it a 2 over 2, so it has a common denominator, and we get a leftover of just 1/2. So this is my equation for my tangent line. Y equals negative 3/10 x plus 1/2. Now for number 9, it says find the rate of change of x with respect to p. So this is different. We're not doing dx this time on the denominator. It's going to be dp. And the way this is set up, it's actually sort of nasty to take the derivative the way it's written. So I'm going to do a little trick just to manipulate this. And I'm going to multiply both sides by the denominator of the right side. So I'm not going to distribute anything. I'm just going to write it as 0.00000. There's 5 zeros there. 3x squared plus 0.04x plus 6 times p equals 5 times 1, so that's just 5. And then I'm going to divide the p over. And that just makes the part that's actually the derivative that I'm going to have to take, which had all these x's in the denominator, they move to the top by doing this. And it's a little bit easier to take the derivatives. So it's just mainly a cleanup to make life easier for the next step. So I'm going to divide the p over. Okay, so then we're taking our derivative with respect to p. So anytime we don't have a p, we have to tack on a d variable, dp. So the derivative of this first term is in respect to, it's a x, so it's not our respect to p, so we're going to have a chain rule here. But we have to do 2 times 0.000003, which would make that actually 6 now, x, and then we'd have our dx dp, so derivative of x with respect to p, plus 0.04 would be the derivative of this, but we have to chain on that dx dp again. The derivative of 6 is nothing, so that goes away. And remember, you can write 5 over p is 5 times p to the negative 1. So this will be negative 5 over p to the second, because it would be p negative 2 when you subtract your power. So if I do this, I can then pull out the dx dp, because we're looking for that rate of change, and that would leave me with 0.000006x plus 0.04 equals negative 5 over p squared. And the only thing I'm going to do to make this better, of course, is to divide over that last part. When you divide it, you don't need to put negative 5 over p squared like on top of this. You can think of it as negative 5, and there's a p squared already in your denominator, and you're just adding this new part down there in the denominator as well. 6x plus 0.04. So that is a nice format that would be easy to plug into. So dx dp is negative 5 over p squared times the parentheses of 0.000006x plus 0.04. Okay, and then we had one more remaining problem, because I told you not to worry about number 10, and that was, it was our number 10 in section 2.8. We don't worry about number 10 in 2.7. So this is an air traffic problem, so we got airplanes that are flying towards each other. It says an air traffic controller spots two planes on the same altitude, so they're at the same height currently. So imagine having a height, and I'll do that in blue. This is our height, essentially, and you've got airplane 1 and airplane 2, and right now they're at the same height. Ignore that that is not a straight line, but that's where they're at. And they're flying at right angles to each other. So that means they're going to be flying towards each other. And that place where they're going to have impact if they don't change their course, this is called the point of convergence, or as most people would just say, impact. That is at a right angle. Okay, so let's talk about what else we know, because this is obviously a right triangle, so we're going to be using Pythagorean Theorem, probably involved here. So let's just name our sides. We're going to name this side, we don't have to call them A and B, we can do X, Y, and Z. So we're also going to need to know about, since we're taking a rate of change usually in these problems, we're going to need to know about dx dt, dy dt, remember that's change in a distance over time, in other words, a speed, and dz dt. So we're looking for all of those things. So it says one airplane is 150 miles from the point, so we're going to call that this one just because I didn't draw anything to scale. So this is 150 miles. And that plane is traveling at a speed of 450 miles per hour. So that is our dx dt. The other one is 200 miles from the point, and it has a speed of 600 miles per hour. Okay, at what rate is the distance between the planes changing? So we're looking for dz dt, the distance currently between these two planes. Because as they're moving towards each other, imagine keep drawing that right angle, that triangle, it's going to shrink z. Because eventually when they meet, there will be no distance between the two planes. So we have to find z, because we're missing that. This is what we're looking for, but we need z as well. So we can use the idea that this is Pythagorean theorem, and we know both legs to find z. So that's x squared plus y squared equals z squared. And when I worked this out, I didn't write all my numbers down earlier, but I'm just going to tell you what this comes out to. It comes out to a perfect square when you take the square root, and it's 250. So currently the two planes are 250 miles away from each other. Okay, so let's take all that we know. So we know that our formula for how these units of measure are all related to each other is the Pythagorean theorem. We're going to take this derivative with respect to time, since we're talking about a rate of change of distance over time. So this would be 2x dx dt, since that's not technically a t, plus 2y dy dt equals 2z dz dt. So notice the one we're missing is over here. So I know that this is 2 times 150 times 450 plus 2 times 600, no sorry, 200 first, 200 times 600, and then this is 2 times 250 dz dt. So we get that this is 135,000 plus 240,000 equals 500 dz dt. If I add those together, I get 375,000 equals 500 dz dt. Divide by 500, and we're going to get that this is 750 miles per hour. And it is supposed to be negative. Oh, and I think that's, yeah. And that's because this distance is shrinking, but it's, yeah, this is a decreasing